So because what it gives you is actually just a WebSocket, this WebSocket is bound to these delegates. So we can accept these states when the socket creates a connection. It also has some tick and some flash-related things. Okay, let's ignore that for now. Let's first continue with what we need to do next. Let's go to our server collection area. We need to do a simple encapsulation of it, because right now it only gives you this pointer. Actually, we need to wrap some additional information around this pointer. Something like GUID information. Okay, we'll manage this here. First, we need to forward declare this thing. Okay. Then, this file, we need to include this type, because we need to define some of these access states. So let's include this type as well. Okay, I'll just define this directly for everyone here. There's no need to guess step by step. I'll put the struct in now. We didn't use smart pointers here. We'll just write it as a struct. But your design is better. Actually, you should use smart pointers here. But it's fine either way. Then let's write a public. Let's write a constructor for it. This constructor needs to take in such an object. With this object, we can then create this instance, because each server connection needs an object. Then we have a function like this here. That is, when we copy it, we can copy it like this. Yes. Then we also have a corresponding constructor here. Okay, here we remove the other unused constructors. We delete all of them. We don't want these constructors to cause unexpected copies in other situations, or moves, or similar cases. So we remove all the other constructors. Okay. Then next, we need to prepare several other methods. These should be relatively simple. Let's finish writing the header file first, because this is a data definition. If we take it apart, it will be hard for everyone to understand. Then we send the message. That is, we send it this way. Send it through this. Of course, this message, we haven't defined it yet. We will define it later. And then we need a tick. These 3 ticks, we won't use them yet. Then I'll stop here for now. We won't write this for now. Leave them blank for now. These are for calculating a time. Then this question is our actual POQs. This with webcon passed down from our upper layer. It is through it that we can send data. Then this collection ID, right, is what the client must bring during its first communication. Then this is the collection ID that the server needs to cache after our first communication is complete. Then we have an enum here. This enum is used to indicate the current state of our connection, and also our internal time. Okay, then next, let's fill in these 2 structs for everyone. Let's go to our place. We still can't jump in yet. We'll start from here. Okay, first, we need to add this action type. What is this action type? It actually identifies what information we need. First, ignore this long. Long is obviously this useless field. Max is also a reserved field. This is the field we use during initialization, and this is the field we use when doing the heartbeat. So these are all used by and this one. Actually, this is what we expose to the user. User communication, it communicates based on this action type. Of course, they can wrap another layer on top of the communication technology. That is completely fine. And this is our logout. One type is server request. Tell me, client request, tell the server. It tells the server that this client is logged out. Another type is the server wants to log out. It tells all clients that it is logging out. So this indicator is just simply defined, a piece of communication information. Now I will take this. We will take the type of this link, each sentence of the current state of the link, define it for him. Then let's look at the server side first. First of all, long and max don't need to be looked at. Then, as for this place, because the link on our side needs to wait for the client to come in before we create it. So the first state is waiting for the client to roughly process this process. After the first communication, after we exchange the collection ID, we will have the next steps. Then tick is our long term. Actually, it keeps the heartbeat. So at this point, it is in the communication phase. This tick will perform a time accumulation calculation. Then this exit is specifically for handling exits. That is how we handle these 2 states. Similarly, on this side, this side actively. This connection has just been created, but has not yet connected to the server. Connect to the server and wait for the server to respond. After that, it enters tick for communication. So here, obviously, we turn it on for him. Cut it. Obviously, this place also has this communication phase, right? And there is also this exit phase. There is also a timeout. That's roughly the idea. Then, with these in place, we can define our communication message. This struct, actually, this is the information for our first level service. It is also relatively simple. First, there is a code. Then we have an action that identifies what kind of message it is. And then, in this communication, this is the connection ID corresponding to the client and the connection ID corresponding to the server. Then, here is a brief description of this session. And finally, this is the data that the user needs to carry. Okay, let's take a quick look. This is relatively simple because we have written it many times before. Okay, then let's go back to this collection section. Here, we have prepared these data structures. Next, let's implement these methods. Okay, let's go ahead and create its implementation. Let's check if there are any issues here. Okay, then let's look at our constructor. What kind of things do we need to do? First of all, we simply copy some rough variables. First, this WebSocket we passed in, we need to hold this pointer. Then here, we need to set our collection ID. Set it to 0, assign a 0 value. Then next, we need the server's ID. We leave 1 because we are currently on the server side. This ID, we let it be constructed when it is built. Then error. Then after that, we set this state. Also enters an error state. Then here we might have this kind of after moving. Can copy in this case. Then here we just need to copy the other one over. That's it. Then this is equivalent to the one you passed in. We just need to make a copy of it. Okay, of course, when you copy here, we need to pay attention to the issue of shallow copy vs deep copy. So we continue writing below here. We copy this WebSem pointer because the previous ones are all numeric values. You can just copy it directly. Then this part might involve this. Then we need to point the original pointer to a null. Point to a null. This is to avoid this. That is, we let it always uniquely hold such a piece of information. The information provided by the web. Then when we destruct it, if this pointer is not null, we need to delete this pointer. Because this is C, fula. Otherwise, this thing in memory will never be released. As for sending the information, it's actually quite simple. Actually, we don't have the need to send this information yet. But since we've already written this far, let's just finish it all in one go. Otherwise, if we miss something, or have to make up for it later, it's inconvenient to go back to school, you see. Okay, let's prepare a message. Prepare a message. And this is the information we want to send. So this information needs to go through some processing. So here, first we convert this struct into our stage. Obviously, we need to include the header file here. Okay, just include it directly here. Okay, these header files should be fine. No problem. Okay, so here after converting it to a hierarchy, we need to prepare a custom data, because this part requires us to handle it manually. Custom data, because the communication protocol between our server and client is defined by us, then we just need to call the server socket from our struct, then let it call and pass our custom data in. Filling a false here. This is done through this method. Send it this way. This version is this Wishient. Actually, it's this. It's through its send method, which sends raw data to the remote end, right? We need to give it a true, give it a false. Because it might add some other data like that. So don't let it add that. Yes, then here we prepare a method. Go to our YouTube here. Our YouTube was left empty before. So we need to prepare a YouTube method here to convert this data. The conversion here might not be written very conveniently, but we can basically use it. So first of all, let's look at what these three methods do. The first method takes an fstream and turns it into binary data. Once you do that, we call it Encode. Then you'll definitely need to decompress it back. To decompress it back, you can pass in an array like this, or you can pass in a pointer. It's essentially the same. Then next, we need to create its implementation. Okay, so for this implementation, how do we write it? First of all, we definitely need to convert this encoding into UTF8 format, because this is the standard. If you don't convert it to UTF8, you might use it internally. and have no issue because both sides are Unreal Engine. But if it involves other platforms, then if it's not UTF-8, others won't be able to parse it. This format of your tar, then we give it a Base64 encoding, right? We encode it with Base64. After the encoding is complete, we need to extract this data. The way it's written here is a bit magical. We write it like this. Essentially, we extract it character by character and then put it into our UTF-8x. Then finally, we return and output this position. Okay, the way it's written here is quite special. Yes. Okay, next then, we will decode 8. After decoding it, so how do we decode it? First, we prepare two variables. One is index. The other is a Base64 str. Then we iterate. Then we iterate through it. Then we should add them up. Yes, after adding them up, we prepare an array. Then we perform a Base64 decode on it. After decoding, let's reverse it. Essentially, we take the previous process and go through it in reverse. And finally, we convert it into offstring. Then we can return this information as data. Okay, here, this part above is actually the same. Then you first sum up all this data. After summing it up, then you decrypt it. This decryption, after decryption is complete, then convert it into fstring. So this is our self-defined binary communication data format, right? Okay, after this is done, then go back to our server colon. When sending, we can call this method. Let's take a look at this method. It should be this one. We probably didn't rename it. We wrote it here. So let's move it back. We move it here. Use this. As for this part, this method is not exposed for internal use. A method. Then we attach it like this. Okay, we don't want to have already written it in the wrong place. So let's delete the one in BP library. This BP library is meant to be exposed to the attack method is exposed for use in Blueprint. So this part still needs to be handled. Okay, let's take another look. This should be able to compile successfully. Good, same as before. Should be no problem. Okay, it's just that we changed this name. It is this name. Now look at our holy sun. It should be correct now. Okay, so this is something that sends data. Then next, let's improve our heartbeat. As for this heartbeat, first of all, we simply calculate the value. That is, when we update. This is when we update each time. Each time we receive a message. When sending heartbeat information, we update this. How do we determine if it is outdated? If we just set it to the default here, if this heartbeat, actually, you need to expose this. Make it a configurable parameter. If the heartbeat is faster, the pressure is greater, but it is also more accurate. This needs to be, this 10 seconds. Let's just set the default to 10 seconds for now. And during tick, we only need to accumulate the rows, and that's it. And of course, this tick, since we are writing our own struct, we will need to embed this tick into our engine's main flow, so that it ticks once per frame. So the tick here needs attention. We haven't written it yet. Okay, here we have essentially completed this lesson. We have essentially defined this ServerConnection. We have also defined our encryption and decryption. Then we go back to this method. This method should be this method. We should be on this method now. We haven't written anything yet, right? We'll wrap it in shortly. Then before we continue writing, let's compile first. To avoid those issues, okay, there's a problem here. Let's take a look. What is this issue about? We need to scroll to this kind of problem. We need to scroll to the very top. Obviously here, it might require a forward declaration. A forward declaration should be needed here. Let's compile again. Okay, there are fewer issues now here because we used this enum. So we need to include this. There's no way around the situation. Our public should be able to include it directly. Okay. We should put it below. So this rhythm issue must be placed below. Okay, let's compile again. Okay, let's take another look. This is a problem with 2 decode like this. Let's take a look. It says deletion of income linked to the time of ILO circuit server is low. So obviously, here we might need to include this thing directly. Because why is it like this? Because it might be related to this Unicode subpointer. There's nothing you can do about it. There's no way to accommodate it. Maybe when they made this subpointer. Okay, let's compile it again now. See, it compiles successfully like this. It's also good to demonstrate to everyone. We often make these mistakes sometimes. There is actually another type of this mistake, this kind of reflective struct. There's no way to fill in the declaration either. You must include the file that declares this struct. You must include this file. Alright, we'll stop here for this lesson. Thank you everyone.